Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So we are on lecture number 2 of quadratic equations. Okay, in the previous session we have learned about remainder theorem and the factor theorem. In today's session we are going to practice more questions on quadratic. We are going to be discussing about nature of roots of quadratic. So this session is going to be really informative and really important for all of you, plus very interesting. Yeah, relation between roots and coefficients. So for a quadratic equation, a general quadratic equation looks like this, right? Ax square plus bx plus c is equal to 0. This is the general face of a quadratic equation. You know how to find the roots of this equation, right? Everybody knows about this famous Dharacharya formula. X is equal to minus b plus minus under root of discriminant. Under root of discriminant, where what is discriminant? Discriminant is b square minus 4ac. So under root of b square minus 4ac divided by what? Divided by 2a. This is how we find the roots of a quadratic equation. Okay, there is plus, there is minus, so definitely there are going to be two roots depending upon the discriminant. That how is the discriminant? We'll be discussing about nature of roots in a short while. Okay, but first of all we want to discuss about the relation between the roots and coefficients, like the sum of the roots. Sum of the roots of a quadratic alpha plus beta is equal to minus b by a. The product of roots alpha into beta is equal to c by a, and the difference of the roots is under root of d by modulus of a, where d is what? D is b square minus 4ac, discriminant. Okay, how do we get to this alpha minus beta part? It's very simple. See everybody, there's a very famous identity that alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Okay, alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Write this down in your copy and you check it. Yes, this is correct, because alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta, and there is minus 4 alpha beta. 2 alpha beta minus 4 alpha beta will give us what? Minus 2 alpha beta, which is same as left hand side. So from this thing we derive the formula for alpha minus beta, because everyone knows that alpha plus beta is minus b by a, so I'm going to put its value as minus b upon a. Everybody knows that alpha beta is c by a, so if I put the value for alpha beta as c upon a, putting the value for sum of roots minus b by a, putting the value for product of root c by a, from here I will get the value for alpha minus beta. So this formula is derived from this particular identity. So the value for difference of roots is equal to under root of d by modulus of a. Okay, now let's practice some questions on it. If alpha and beta are the roots of this equation, then find the value for alpha square plus beta square. Okay, now everyone, see, we can't find the roots of this equation individually, although we can find it, but it will be imaginary, right? The roots of this equation, if you check the discriminant, discriminant is 2 square minus 4 into 3. The roots are imaginary. Okay, clear? How do we get the value for alpha square plus beta square? Because we know the value for alpha plus beta. Alpha plus beta is minus 2, and the value for alpha beta is plus 3 for this equation. The sum of the roots is minus b upon a, which is minus 2, and the product of the roots is c upon a, which is 3. So alpha plus beta is equal to minus 2 and alpha beta is equal to 3. Now how do we get to this value, alpha square plus beta square? So it's very simple. Just square it. Just square this equation. So alpha plus beta whole square is equal to minus 2 square, correct? Alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. In the right hand side I'm getting 4. I have the value for alpha beta as 3. So alpha square plus beta square plus 2 times 3 is equal to 4. So the value for alpha square plus beta square, alpha square plus beta square is 4 minus 6. 4 minus 6 will be minus 2. So that's our answer. That's the value for alpha square plus beta square. Yes, we are getting a negative value. Because alpha and beta are not real numbers, these are imaginary numbers over here. The square of a real number is positive, but a square of an imaginary number is negative. Okay, so we have imaginary roots for this equation. Now, if they ask us the value for alpha cube plus beta cube, how do we get that? So again, we know the value for alpha beta, which is 3, and alpha plus beta, which is -2. This time I'll be cubing on both sides. So in the left hand side I have alpha plus beta whole cube. In the right hand side I have -2 cube. So in the left hand side I get alpha cube plus beta cube plus 3 alpha beta times alpha plus beta. In the right hand side, -2 cube is -8. I hope that all of you understand the formula of a plus b whole cube. Okay, now do we have the value for alpha plus beta? Yes, the value for alpha plus beta is -2. Do we have the value for alpha beta? Yes, the value for alpha beta is 3. So from here I can get the value for alpha cube plus beta cube like this. Alpha cube plus beta cube plus 3 multiplied by 3 multiplied by -2 is equal to -8. 3 multiplied by 3 multiplied by -2 is equal to -8. So this is 3 3s are 9, 9 2s are 18. So -18 goes to the right hand side. That will become +18. So alpha cube plus beta cube is equal to +18 -8, which is equal to 10. As simple as that. Okay. Clear? This is a similar kind of question. Now, if alpha and beta are the roots of equation, then form the equation whose roots are. So this time we'll be talking about forming a quadratic equation. A quadratic equation. See, to form a quadratic equation, we just need two things: sum of the roots and product of the roots. Okay. If I have the sum of the root as s, let s is sum of roots, and p is product of roots, then the quadratic equation is x square minus sum of roots times x plus product of roots is equal to 0. This is our required quadratic equation. Okay. Forming a quadratic equation, I just need two things: sum of roots and the product of root. If I have these two, basically sum of roots is alpha plus beta, right? S is alpha plus beta. Okay. This is alpha plus beta. Product of roots, basically alpha into beta. If I have the value for alpha plus beta, if I have the value for alpha into beta, I can make the quadratic equation like this: x square minus sum of root times x plus product of roots is equal to 0. Cool? Simple. Now, let's get to the question. Okay. Let's get to the question and the reason behind it. If you are wondering that, sir, what's the reason? What's the reason behind it? So it's simple. See, this quadratic is nothing but x minus alpha into x minus beta. See, if you give me the roots as alpha and beta, if you say alpha is a root, beta is a root, so definitely these two are going to be the factors of that quadratic equation. And if you multiply this, this is x square minus alpha plus beta times x plus alpha beta is equal to 0. The product of these two factors is gonna give you this. And what is this? This is sum of roots. This is what? Product of roots. So its proof is so simple. Just one line proof. If alpha and beta are the roots, x minus alpha into x minus beta is equal to 0. This is the equation. If you multiply these two, this is what we get. Now, what is alpha plus beta? Sum of roots. What is alpha beta? Product of roots. That's it. Okay. So, x square minus sum of roots into x plus product of root is equal to 0. This is how we form a quadratic equation. Now let's get back to this question. If alpha and beta are the roots of this equation, ax square plus bx plus c is equal to 0, then I have to form an equation whose roots are 1 by alpha and 1 by beta. Okay, the equation whose roots are 1 by alpha and 1 by beta. Very, very important question. This question has been directly asked in JEE in previous years. So how do we tackle this question? We are looking for sum of roots, we are looking for product of roots. Basically, the sum of roots is going to be 1 by alpha plus 1 by beta. And the product of roots is going to be 1 by alpha multiplied by 1 by beta. We are looking for the value of these two things. If we have that, we have the quadratic equation. Okay. Now 1 by alpha plus 1 by beta will be alpha plus beta upon alpha beta. Do we have the value for alpha plus beta? Yes, because alpha beta are the roots of this equation. So we have the value of these two things, right? That alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. These are the two informations I already have from the equation, from the given equation. Okay, now alpha plus beta, I'm going to put its value as minus b by a. Okay, and in the denominator, the alpha beta, I'm gonna put its value as c by a. So minus b by a divided by c by a will give us minus b by c. And this is so simple. 1 upon alpha beta, basically 1 upon, we have the value for alpha beta, which is c by a. So it will be a by c. So we have the value of s, which is minus b by c, and the value of p, which is a by c. So now our required quadratic equation with the roots 1 by alpha and 1 by beta is going to be x square minus sum of roots into x plus product of root is equal to 0. X square minus, what's the sum of root? Minus b by c. So minus b by c times x plus, what's the product of the roots? The product of the roots is a by c. So plus a by c is equal to 0. Minus of minus, this term will become plus. Take the LCM with c, there is c in the denominator, here also we have c in the denominator. Taking the LCM, we get the quadratic equation cx square plus bx plus a is equal to 0. Take the LCM, then multiply the denominator to the right hand side. So this is our answer. This is our answer. See everybody, what did you learn in this question? You learned in this question that if the roots of ax square plus bx plus c barabar 0, if its roots are alpha beta, the roots of this equation is going to be 1 by alpha and 1 by beta. Okay. Now you need to directly absorb this result. That if question comes to you like this, that what form an equation whose roots are reciprocal of the roots of this equation. So what you simply need to do, you simply need to interchange a and c. That's the trick. Okay. Simply interchange coefficient of x square and constant term. We get to our answer. Okay. We get to our answer. Simply interchange these two. So this is the process. Finding sum of roots, finding product of roots. If we can do that, we can form our required equation. Okay. Now, this time I need to make an equation whose roots are this and this. These are the roots. So what's the sum of the roots, everybody? The sum of the roots is going to be alpha plus 1 by beta plus beta plus 1 by alpha. That is going to be our sum of roots, which is equal to, here we have alpha plus beta. Here we have 1 by alpha plus 1 by beta, which is alpha plus beta upon alpha beta. Right? 1 by alpha plus 1 by beta is going to give you this. Now, can you put the value for alpha plus beta? Yes, the value for alpha plus beta is minus b by a. The value for alpha plus beta here, minus b by a. And the value of alpha beta plus c by a. So here we have minus b by a and minus b by c. Okay, minus b by a minus b by c. Okay. So this is the sum of the roots. This came out to be sum of the roots. Now let's talk about the product of the roots. So product of these two roots is going to be alpha plus 1 by beta multiplied by beta plus 1 by alpha. Now multiply these two. What do we get? Simply you can multiply this, that alpha into beta, alpha into 1 by alpha, 1 by beta into beta, 1 by beta into 1 by alpha, right? So here we have alpha into beta plus alpha multiplied by 1 by alpha will give us 1. 1 by beta multiplied by beta will give us 1 again. 1 by beta multiplied by 1 by alpha will give us 1 upon alpha beta. Okay. So now you can put the value for alpha beta as C upon A, plus here we have 2, 1 plus 1, that will be 2. 1 upon alpha beta will be A upon C, putting the value for alpha beta as C by A here. Okay, everybody. So this came out to be our product of roots. If we have these two things, now I can form our required equation that x square minus sum of roots into x plus product of root is equal to 0. So x square minus, what is sum of the roots? Minus b by a minus b by c. So minus b by a minus b by c times x plus, what's the product of the roots? C by a plus a by c plus 2. C by a plus a by c plus 2. This is the product of the roots is equal to 0. This is our required equation, which is x square plus, if you take b common, we get 1 by a plus 1 by c times x, plus we have this. Okay. Or you can take LCM also over here. So we have b times a plus c upon ac. Okay, if you take LCM. So we have b times a plus c upon ac. Here if you take LCM, you are going to get c square plus a square plus 2ac, means c plus a whole square by ac. This is what you are going to get. See, c by a plus a by c plus 2. Take LCM, you get c square plus a square plus 2ac in the numerator, which is c plus a whole square. Okay, taking LCM by ac. So now our required final answer is going to be ac x square plus b times a plus c into x plus c plus a whole square is equal to 0. This is our final answer. This is our required equation. Okay, everyone? Cool? Simple? No. So I hope this type of question is pretty much clear to each and every one of you, and how to tackle these type of questions. You just, if you want to form an equation, just get the sum of roots and product of the roots. You can form an equation. As simple as that. Okay, moving ahead. Like this question. If alpha and beta are the roots of this equation, 6x square plus 5x plus 3 is equal to 0, then the equation whose roots are 1 upon alpha plus 1 and 1 upon beta plus 1. We want to make an equation again whose roots are this. Okay, so first of all, get the value for sum of the roots, which is 1 upon alpha plus 1 plus 1 upon beta plus 1. Get their value. Okay, take an LCM. So here you get beta plus 1 plus alpha plus 1 upon alpha plus 1 multiplied by beta plus 1. Okay, this is how you take an LCM. Now we have the value for alpha plus beta over here, because alpha plus beta is going to be minus b by a minus 5 by 6, and alpha into beta is going to be c by a, which is 3 by 6. Okay, multiply the denominator. So alpha plus beta, let's put its value as minus 5 by 6, or you can just put alpha plus beta plus 2. Okay, if you multiply the denominator, you get alpha beta plus beta plus 1. See their product, alpha into beta, alpha into 1, 1 into beta, 1 into 1. This is what you get, right? So the value for alpha plus beta, minus 5 by 6. So we have minus 5 by 6 plus 2. In the denominator, we have alpha beta, which is 3 by 6, plus alpha plus beta, which is minus 5 by 6 plus 1. So this is the sum of the roots. You just have to calculate this. 6 2s are 12, 12 minus 5, 12 minus 5 will be 7. So 7 by 6 in the numerator. In the denominator, we have 3 by 6 minus 5 by 6, which will be minus 2 by 6. minus 2 by 6 plus 1. Okay, so that will be 4 by 6. So 7 by 6 upon 4 by 6, which will be 7 by 4. This came out to be the sum of the roots. Now let's calculate the product of the roots. So product of the roots, which is 1 upon alpha plus 1 multiplied by 1 upon beta plus 1, which is going to give us 1 upon alpha plus beta plus 1. Okay. Now what's the value for alpha beta? The value for alpha beta is 3 by 6. Alpha plus beta minus 5 by 6 plus 1, which is going to give you what? Minus 2 by 6 plus 1. Minus 2 by 6 plus 1. Okay. Minus 2 by 6 plus 1. Okay. Which is 4 by 6 in the numerator. 4 by 6, that will be 6 by 4. So product of the roots is going to be 6 by 4. Okay. This is coming in. Or you can write it as 3 by 2. Now let's write our final answer. So what will be the equation? The equation is x square minus times sum of the roots, which is 7 by 4, x square minus sum of roots into x plus product of roots. The product of roots is 6 by 4 is equal to 0. Okay. Yeah. Correct. So x square minus 7 by 4x plus 6 by 4 is equal to 0. So we get 4x square minus 7x plus 6 is equal to 0. 4x square minus 7x plus 6 is equal to 0. Let's just quickly check our calculation. If we have done any calculation mistake, that can happen with anybody. Alpha plus beta minus 5 by 6, alpha beta 3 by 6. That part is correct. Okay. So here we have alpha plus beta plus 2. In the denominator, we have alpha plus 1 multiplied by beta plus 1. This is the thing. Alpha plus beta, if I put minus 5 by 6, take LCM, 6 to the 12, 12 minus 5, 7 by 6, correct. Alpha beta is 3 by 6, alpha plus beta minus 5 by 6, plus 1. Okay. 3 by 6 minus 5 by 6, that will be minus 2 by 6. Minus 2 by 6 plus 1, that will be 4 by 6. Right. So we have 7 by 6 upon 4 by 6, which will be 7 by 4. 7 by 4 in the numerator. Okay. And okay, there's a mistake over here. There's a mistake. No, this is correct. 7 by 4 only we are going to get. Okay. And what do we have here? We have 4 by 6 in the denominator. 4 by 6 will be 6 by 4. So if I put these values, x square minus sum of roots into x plus product of roots is equal to 0. So I'm going to get the answer 4x square minus 7x plus 6 is equal to 0. So I think we have done the calculation correctly. Okay. So I just checked from the source of the equation. Yes, our answer is definitely correct. There is no mistake. There is nothing. Our answer is correct. Options are not correct. That's the problem. Yes. None of the following is the right answer. So this will be 4x square minus 7x plus 6. That is our right answer. That is the final answer. 4x square minus 7x plus 6 is equal. Yes. Our answer can never be wrong. Options can be wrong, but our answer can't be wrong. Okay, this is the right answer. Now let's move ahead. So guys, let me show you some more amazing question. Okay. Let's have a look at this question. If a not equal to b and difference between the roots of this equation and this equation is same, then what is the relation between a and b? This is the question. See, difference between the roots of this equation. So what is the difference of roots of this equation? There are two equations given in this equation. One of the equation is x square plus ax plus b is equal to 0. Another equation is x square plus bx plus a is equal to 0, right? These are the two equations we have in front of us. Let's say that its roots are alpha and beta. Let's say that its roots are gamma and delta. What is given? It is given that difference of these two roots, basically alpha minus beta, and difference of these two roots, which is basically gamma minus delta, they have said that they are same. This thing is given. Okay, let me write it more beautifully. Given that alpha minus beta is equal to gamma minus delta, where alpha beta are the roots of this equation, gamma delta are the roots of the second equation. Now, what's the value for alpha minus beta? That is under root of d by modulus of a, under root of discriminant by modulus of a, right? For the first equation. What is the discriminant for this equation? The discriminant of this equation is a square minus 4b. A square minus 4b. So under root of d upon modulus of a. A is the coefficient of x square. Coefficient of x square is 1. And that is equal to, the same formula will be applied for the second equation. To get the value for gamma minus delta, again the same thing, under root of discriminant. What's the discriminant of this equation? B square minus 4 into a into 1. Basically b square minus 4a. Okay. B square minus 4a divided by modulus of a is the coefficient of x square, basically divided by 1. These two things are the same thing. Now just simply do the squaring on both sides. So in the left hand side we get a square minus 4b, in the right hand side we get b square minus 4a. Just arrange the terms. So I'm bringing a square and b square to the same side. So here I get a square minus b square in the left hand side. In the right hand side I'll get 4b minus 4a, sending this minus 4b to the right hand side. So a square minus b square, there are two factors to it, which are a minus b multiplied by a plus b. Here if I take 4 common, it is 4 times b minus a. Okay. Now, because a and b are not equal, so definitely this thing is a non-zero thing. This thing is a non-zero thing. If I divide by it, b minus a upon a minus b will give us minus 1, or I can simply say that I'm cancelling out these two factors. I'll get minus 1 in the right hand side. So the value for a plus b, I'm getting the value for a plus b as 4 into minus 1, which is minus 4. A plus b is equal to minus 4. That's the right answer for this question, which is option A. A plus b is equal to minus 4. Correct? Very simple. Okay. Now, relation between roots and coefficients, let's talk some more about it. In the previous session, I have told you that for a cubic equation like ax cube plus bx square plus cx plus d is equal to 0. For this cubic equation, we have three roots alpha, beta, gamma. The sum of the roots minus b by a. Sum of the roots taken two at a time, alpha beta plus beta gamma plus gamma alpha, c by a. Alpha beta gamma minus d by a. So this is the pattern you need to remember, or you just need to remember the first thing. See, minus b by a will be sum of the roots. Sum of the roots taken two at a time plus c by a, product of the roots minus d by a. So there is a pattern of minus plus minus. Just remember, okay, just remember the pattern. Which pattern? The pattern of, just remember the pattern of minus b by a plus c by a minus d by a plus minus plus minus plus. Just remember this pattern. This is sum of roots taken two at a time, sum of roots taken three at a time, sum of roots taken four at a time, and so on. Here I have only three roots, so we'll stop here. Okay, we are taking all the roots, alpha into beta into gamma. Here we are taking two roots at a time. Here we are taking one root at a time. Sum of roots taken two at a time, sum of roots taken three at a time. If you wanna learn about its derivation, you can watch the previous lecture. In the previous lecture, I have derived this as well. Or if you just directly want to remember, that's also cool for me, for you also. Now, for a degree 4 equation, this is a degree 4 equation. The same pattern continues. Sum of roots Sum of roots taken 2 at a time, sum of roots taken 3 at a time, sum of roots taken all at a time. Alpha, beta, gamma, delta. Sum of roots taken all at a time means product of roots only. Okay, here we are taking sum of roots taken one at a time, minus b by a plus c by a minus d by a, then again plus e by a. There has to be plus here. Minus, plus, minus, plus. This is the pattern that follows. Okay, let's have a look at some examples. This is a cubic. Then write the relationship between zeros. Zeros means roots and the coefficients. So if I write alpha plus beta plus gamma, then alpha beta plus beta gamma plus gamma alpha, then the value for alpha into beta into gamma. These are the three values we are looking for. So this is minus b by a plus c by a minus d by a. What is a? A is 3. B is minus 5. C is minus 11. D is minus 3. Okay. So minus, what's the value for B? Minus 5 by the value for A is 3. So minus of minus 5 by 3, that is plus 5 by 3. Okay. Minus B by A. See, B is already negative. So minus B by A will give us positive. Plus C upon A. So C upon A means minus 11 by 3. The value for C is minus 11. Then minus D by A. Okay, D is minus 3. So minus of minus 3 divided by A is 3. So this will be 1. So that's it. This is our answer for this question. Okay. Now, try this question. Try this one. Pause the video. Try this question. Let me know the answer. Okay, some of the roots we are looking for this cubic equation. Just give the answer. You might do a mistake, and see, mistakes are very, very important in mathematics. Okay, you learn from your mistake. You remember from your mistake. Okay, you learn from your mistake, and more importantly, you remember the thing that you have done wrong in a question. Okay, now we are looking for alpha plus beta plus gamma, hai na? If alpha, beta, gamma, this question should be changed to, if alpha, beta, gamma are the roots of this equation, then what's the sum of the roots of this equation? Okay, so this is a cubic equation, x cube plus, see, we don't have the term of x square, so just I can write 0 times x square, or simply you know that alpha plus beta plus gamma is what? Minus b by a, right? What is b? Where b is the coefficient of x square. See, if there's a cubic like this, ax cube plus bx square plus cx plus d equal to 0. This is the general face of a cubic equation, correct? Now, if you compare this equation with this given cubic equation, what do you see? You see that a is 1, but there is no term of x square. So you see that b is 0. You see that c is minus 2 and d is plus 1. If I am asking sum of the roots, the formula remains the same, minus b by a. What's b? B is 0. So it is 0 only. Okay. So option A is our right answer for this question. Correct? Now, you can note this note. This note works in many questions. Whenever we are finding or proving some condition and during the procedure we get the value of some root, always make it satisfy the equation. See, simple logic, that if alpha is a root of this equation, alpha will satisfy that equation. As simple as that. Okay. See, how do I use that in questions? There's a question in this. If 2, 3 are the roots of this equation, then find the value for m, n and the third root. See, 2 roots are given. 2 is the root of this equation. So 2 will satisfy this entire equation. And the same goes for 3. 3 should also satisfy this equation because it is the root of this equation. So if I satisfy 2, basically in place of variable x, I put the value for x as 2. I get 2 times 2 cube plus m times 2 square minus 13 times 2 plus n. That should be equal to 0. So what do I get? This is 16 plus 4m minus 32 plus n is equal to 0. So from here I'm getting 4m plus n. 4m plus n, 16 minus 32 will be minus 16. So 4m plus n is equal to plus 16. That's what I have. The same goes for 3 as well. That 3 also satisfies this equation. In place of x, if I put 3, that also satisfies this equation. So I get 2 times 3 cube plus m times 3 square minus 13 times 3 plus n is equal to 0. Right? 3 cube, 27. 27 to the 56. 54, right? Yeah. Then 3 square 9. So we have 9m. This is minus 39 plus n is equal to 0. So from here, what do I get? I get 9m plus n. 9m plus n. Okay. 54 minus 39. So 40 and 15, right? So plus 15, or you can say is equal to minus 15. This is what I get. That 9m plus 9 is equal to, if you send this term to the right hand side, minus 15. Now, using this equation 1 and equation 2, you can find the unknown m and n. So if you know the roots, you can satisfy the equation. As simple as that. Okay. Now, if you subtract these two equations, equation 2 minus equation 1, 9m minus 4m will be 5m. N will get cancelled out. Minus 15 minus 16. Minus 15 minus 16 will be minus 31. So the value for m is equal to minus 31 by 5. This is the value for m. Right? In the similar way, the value for n is going to be, if you put the value for m in any of this equation, put the value for m, you get the value for n. That 4 times minus 31 by 5 plus n is equal to 16. From this equation, you can get the value for n also. What else they are asking? They are asking us about the third root. That what's the third root? Okay. So, yeah, calculation wise. Okay, we have done a mistake here. 26, there should be 26. Okay. So 16 minus 26, that will be plus 10. In the right hand side. Okay. Now, if I subtract these two equations, I'll get minus 25. Yeah. I'll get 5m is equal to minus 25. So the value of m will be minus 5. If I put the value for m as minus 5, this is minus 20. Okay. Minus 20 plus n is equal to 10. N will be equal to plus 35. I think that should be the thing. Okay. So 2 into 2 cube plus m times 2 square minus 13 into 2 plus n is equal to 0. We get 16 plus 4m minus 26 plus n is equal to 0. So 4m plus n is equal to plus 10. Here I get 54 plus 9m minus 39 plus n. So 9m plus n is equal to, okay, 54 minus 30. Yeah, we are correct with calculations now. So we are getting the value for m as minus 5. We are getting the value for n as 35. Satisfies these two equations. Minus 20 plus 35 will be 10. Yes. Minus 45 plus 35. Okay. Peace. Okay. Minus 5 minus 20, the n will be 30. Okay, I'm getting too much hurried in the equation, the calculation. So we have minus 45 plus 30. Yes, correct. So the value for m is minus 5. The value for n is 30. Right? Now, they are looking for the third root. So some of the roots, alpha plus beta plus gamma. Okay. We know that some of the roots will be minus b by a, which is minus m by 2. That should be the sum of the roots. Minus b by a minus m by 2. Now we already have two roots, which are 2 and 3. So 2 plus 3, and let's say that the third root is gamma is equal to minus m by 2. The value for m is 5, so it will be plus 5 by 2. The value for m is minus 5, so it will be plus 5 by 2. So the value for gamma is 5 by 2 minus 5, which is minus 5 by 2. That is the third root. So this is the third root. These are the values of m and n. I hope this is clear to all of you. Okay. So now let's get to the next topic, which is about the nature of the roots, or we can continue this topic in the tomorrow's session if I don't want to, burden you with the topics. Okay, we have time. We can continue this question now, or this topic still. So discriminant. Discriminant decides the nature of the roots. Discriminant decides the nature of the roots. Okay, I'm not going to go very deep into this topic right now because I have a lot to tell you. I have a lot of questions on this topic. Okay, but for now you can just understand that discriminant defines the nature of the roots. Like, what are the roots? Roots are minus b plus minus under root of discriminant divided by 2a, correct? These are the roots. Now it all depends upon d. If d is positive, then under root of a positive number will be a real number, right? Okay, so if d is positive, if discriminant greater than 0, we are going to get real roots, real and distinct roots. Okay, that you can observe. If d is 0, we get real and equal roots, and if d is negative, we get imaginary roots. That's the thing. Okay, as you can see, we have written this entire thing over here. See, it all depends upon d. If discriminant is positive, we are getting real and distinct roots. If discriminant is 0, we are getting real and equal roots. If discriminant is negative, we will be getting non-real, or we can say imaginary roots this time. Okay, these are the nature of the roots, which is all dependent upon the discriminant. Now see guys, if I am talking about real roots, what are real numbers? Do you know that? In real numbers, we have integers, we have rational, we have irrational. Okay, real numbers consist of two things. Okay, real numbers has two children. The two children of real numbers are rational and irrational. These are the two children of real numbers. What are rational number? We represent rational number by q. Irrational numbers are represented by q complement. Rational numbers are those numbers which can be represented as a ratio. Okay, like 4 by 3, 5 by 2, 7 by 9. Basically, whatever you can represent as a ratio is known as rational number. In these rational numbers, we have all the integers. All the integers are rational number. Okay, all the decimals, which are terminating decimals. Terminating decimals are rational number, and terminating and repeating decimals are also rational number. All of these three things are in the rational number category. Now if we talk about irrational number are non-repeating and non-terminating non-repeating and non-terminating decimals, like root 2, like root 3, Root 4 is not an irrational number. Root 4 is equal to 2. That is not an irrational number. Root of 5 or 7 raised to the power 1 by 3 or under root of 7 or pi or a, basically these are irrational number. Under root of a non-perfect square. See, 2 is not a perfect square. So that is why its under root is a irrational number. If you talk about the value for root 2, it will be 1.41 something and so on. It will be non-repeating and non-terminating decimal. Same goes for root 3, same goes for root 5 and so on. So these are real numbers. What are imaginary numbers? See, imaginary numbers are those numbers in which we have negative inside under root. If we have a negative number inside under root, that number is known as imaginary number. A very famous imaginary number is iota, which is under root of -1. So that's all you need to know about imaginary number for now. You will learn more about imaginary number in the chapter complex number. But see, in real numbers, we can't have a negative inside under root. But the imaginary number has negative inside the under root. Now let's get back to the previous slide. So what did we say? If D is positive, we get real and distinct roots. If D is 0, if discriminant is 0, both of the roots are going to be equal, right? This thing becomes 0. So we get minus B by 2A only, right? So real and equal roots. Imaginary roots if discriminant is negative, because now we have a negative number inside under root, so this will be an imaginary number. Okay, so we have non-real roots. Now guys, see, the thing is, if D is not a perfect square, it is positive but not a perfect square. If D is positive but not a perfect square, then we get irrational number. Then we get irrational roots, right? If D is suppose 3, so we have plus minus root 3. Now the roots are irrational. Let's say D is 5, then we get, irrational roots this time. Correct? Now, irrational roots, if the coefficients are rational, if everything else is rational, this is rational, this is rational, this is rational, and if we are getting irrational roots, then those roots will occur in conjugate pair. Conjugate pair means like 2 plus root 3, 2 minus root 3. These are conjugate pair. 4 plus root 5, 4 minus root 5. These are conjugate pair. Basically, there is a plus minus sign with the irrational term. These are known as conjugate pair. Okay. And the same goes for this. The same goes for imaginary roots as well. Okay, because imaginary roots in terms of iota, see, if discriminant is negative, here I'm going to get iota, and then again I'm going to get roots as conjugate complex number, like 3 plus 2 iota, 3 minus 2 iota. If 5 plus iota is one of the root, other root will be 5 minus iota. But here you have to make sure that everything else is real. Basically, A is real, B is real, C is real, and if this D is negative, then here we have introduced iota. Okay, and there is a plus and minus sign with iota. These are conjugate complex numbers. Okay, so we have conjugate irrational number, we have conjugate complex numbers. Okay, so I'm going to hold on to this story for now. Okay, this is a homework question that you try to find its roots. That is the homework question. Okay, try to find its roots, observe the nature of these roots, and this is also a homework question for all of you. The equation this has, okay, try these two questions. We'll be discussing these questions in the next session, and there are many more questions in store for you guys in the next one. So for now, this is it. Thank you everyone for being a part of this session. See you in the next one. Till then, this is your maths teacher, Kundan Mankar, signing off. Tada, bye bye. Have a great day.